Hello viewers, this is the part 2 of the topic on creating an Oracle 19c database on an Oracle Linux virtual machine following the most common best practices and standards of an Oracle database. So let's start today's tutorial by defining the database layout in terms of storage and resource like CPU, memory, swap, and their footprints on the server. I am explaining this through a table. So obviously our test deployment will be a small one. Now the CPU. The CPU is a critical component that determines the server and the database performance. You can always start with the minimum and then adjust as you go based on your requirements. Here I am allocating two virtual CPUs, RAM or physical memory. The amount of memory is equally critical that determines the server and the database performance. I am estimating for the RDBMS and the OS totaling to a 12 gigs of physical memory size. If you see a lot of paging happening in the server, you may increase it later on. Next, the swap. As per the Oracle recommendation, swap size should be calculated based on the size of the physical memory or the RAM, where for a RAM size between 1 to 2 gigs, the swap size should be 1.5 times the RAM size. For a RAM size between 2 to 16 gigs, the swap size should be equal to the RAM size. And for a RAM size over 16 gigs, the swap size should be also 16 gigs. So in our case, the swap memory size will be 12 gigs because our RAM size is also 12 gigs. Now the storage. I allocated a total of 70 gigs to the server while installing the Linux operating system, and that is divided amongst the root, boot, and the swap file system. But you can start with a minimum of 25 gigs allocation for the root, boot, and the swap file systems during the initial installation of the operating system. The temp file system should be of size 2 gigs minimum for Oracle installation. I am allocating 10 gigs as I am going to install OEM also in this server, and that demands more temp size while unzipping the huge installers of the OEM. Now the file system named U001 is created with a size of 50 gigs for the Oracle RDBMS and the OEM or OMS binaries, logs, trace, and the dump file. Without the OMS installation in this server, you can have it with a size of around 15 gigs. The file systems named U002, U003, U004 are created with a size of 2 gigs each, and they will be hosting the 3 groups of redo logs and the multiplexed control files. The file system named U005 is created with a size of 40 gigs, which will host the data files. And the file system named U006 is created with a size of 25 gigs, which will host the FRA or the fast recovery area. Oracle recommends an FRA size of 3 times the database size, but as we are not going to keep the backup pieces here, so this should be fine. You can have it even smaller initially, like 20 gigs or so, then increase when required. If you create guaranteed restore points and your flashback retention is very high, then probably you will need a lot of space in your FRA. After defining the layout of the database, usually below are the series of activities performed, which are: create the database in no archive log mode first to avoid creating a large amount of archive logs while you create the database, then finalize the initialization parameters, then put the database in archive log mode, schedule the backup jobs, set up monitoring. If you don't have the OEM in place, then you have to set up the general monitoring of the table space, database performance, logs, etc. Apply a mock workload to evaluate the database performance. Analyze the performance using AWR, ASH, and ADDM reports. Make the required adjustments in database and operating system for improvement of performance. Final analysis of the database performance, and then release the database to the users or application. But in this tutorial, we will perform only the first 3 steps, as the remaining steps are out of the scope for now. Now let's put everything in action to create our Oracle 19c database. So I logged into the server named admin SVR, which I call admin server, as Oracle user. Now let's go to the root directory and take a look at the file systems we created for their permissions. And these are the file systems that we created: U002, U003, 4, 5, and 6. The U001 we already used in the last tutorial to install our Oracle RDBMS software, and the ownership of the file system is already Oracle O install. But all the remaining file systems that we are going to use here are owned by root. So we have to first change the ownership to Oracle and group O install. To change the ownership of these file systems to Oracle O install, we have to log in as root because currently they are owned by root. So su minus root, and it will ask for the root password that we already know. And now we are as root user. Let's go to the root directory and change the ownerships using chown command minus capital R for recursive, Oracle O install, and all these file systems here: U002, U003, U004, U005, and U006. And if we see it again, now you can see that the ownership has been changed to Oracle O install. Let's clear it. Now we are ready to invoke the database configuration assistant or DBCA. Now, before running any Oracle utilities like DBCA, the Oracle environment should be properly set, which means the environment variables have to have the proper values. In our case, we don't have to set the environment because in the last tutorial, I have already shown how we can set these environment variables in the bash profile of the Oracle user, so that every time the Oracle user logs into the server, his bash shell will be automatically populated or automatically set with all the environment variables for his Oracle environment. So here we can take a look and see if all the variables are properly set by looking into the .bash profile of Oracle user. Here we can see that the Oracle base, Oracle home, LD library path, Oracle SID, Oracle unique name, TNS admin, and the path variable, everything is already set. Now clear this, and again before invoking DBCA, we can see which DBCA is actually being invoked. So we see the path here, which is coming from the Oracle 19c home, which we installed earlier. So this is the right DBCA, which is going to create the database for us. But before we run the DBCA, the display variable should already have the IP address that belongs to the machine from where you are connecting to the Oracle server. Now we set the display variable with the IP address of the machine, and now we can invoke DBCA. Before we create a database, let's first delete the database that we created in the last tutorial, because that was just a test database we created to validate that our Oracle installation was properly done. So we'll click next, and the database that we created with the name ORCL is selected by default. And here we have to provide the sys password, and using this sys credential, this database is going to be deleted by DBCA. Here we don't have to select anything because this instance was not registered with any Oracle Enterprise Manager. Click next, and these are the files which are going to be deleted from the system. Click finish. It will ask for the confirmation. Click yes, and the deletion activity will take like a minute or so, and the database deletion is completed. Click close, as it doesn't give us the option to go back to create the database, and instead we have to invoke DBCA again. While creating the database, in the first screen, we will select the create a database option, then click next. We will select the advanced configuration option, click next. The database type will be Oracle single instance database. We have other options here like Oracle real application cluster or RAC database, Oracle RAC one node database, etc. And we are selecting Oracle single instance database here. And we will select this option of the template here, custom database, which will give us more flexibility to choose the options. Click next. Here we have to specify the global database name of the database that we are going to create, which will be OEM repo. And you can select any name here of your choice. because we are going to create this database as OEM repository, so I am keeping the name as OEM repo. A global database name is the name of the database along with the domain name separated by a dot, and it uniquely identifies the database within your organization's domain or network. Here, the domain I am using is my example domain named oraexpert.org. The SID, which is automatically selected here by the installer from the global database name, is the system identifier of the database instance that uniquely identifies the database within the host where it resides. And I will unselect this create as container database because it's not a CDB. Click next. In this screen, we will select this option, use following for the database storage attributes, where we are selecting the file system option, and we have here the ASM option also, and the database file location will be our file system, which was created specifically to keep the database files, which is /u005, and rest of the directories will be automatically created. Then multiplex, redo log, and control files. We want to multiplex the control file and the redo log file for this database. Even if we have the option here for multiplex, redo logs, and control files, we are not going to select this option here and now because there is a bug associated in DBCA, and even if you select the multiplex option, those changes or the options you selected are not going to take effect. So we'll skip this. Then file location variable. Here it is showing us all the file locations that are going to be used here, where it has given us the Oracle base home, DB unique name, Oracle base, PDB name, which is blank actually because there is no pluggable database, database name, OEM repo here, Oracle home, which is U001 app Oracle product 19.3 DB home 1, and this was created in the previous tutorial. And the SID of this particular database is going to be OEM repo. Then click next. Specify a fast recovery area. So here we are going to select the part U006, which we created for fast recovery area, and the size it's taking by default as 7 gigs. We'll keep it like this for now, and later on we will adjust it. And enable archiving, this option we are unselecting intentionally because we don't want to enable archive log mode while creating the database to avoid creating a large amount of archive logs. And we will click next here. And there is one listener already created in the previous tutorial while installing the Oracle software and creating the test database, and that listener was with a name listener itself, and it was listening at the port 1521. And this time we are not going to use that listener, so we'll unselect that, and instead we are going to create a new listener with the name listener OEM, and the port will be 1522. It is always recommended to use a non-default port for security reasons, and that is another reason why we are not going to use this default listener. And next we are going to select a few options, and the options we needed are already selected. We are not going to use the Oracle Level Security, Oracle Application Express, and Oracle Database Vault for this database, so we have unselected them all. Rest of the components which are selected by default, we are keeping them like that. Click next. And here we are using the automatic shared memory management, and as we have allocated 12 gigs of memory to the server, and I have already explained that out of 12 we are estimating that 4 gigs will be taken by the RDBMS and rest for the OS itself. And out of the 4 gigs we are allocating 3 gigs to the SGA and approximately 1 gigs to the PGA. You can adjust it if you want the amount of memory used by this instance, but as of now we are okay with this, and if it is required we will be able to increase it in the future. And we are not selecting the manual shared memory management and automatic memory management here. Under sizing, the block size is 8 KB, which is the standard, and the processes parameter, it should be always set at a higher value like 2000. Then the character set, it is the Unicode character set selected by default, which is the best character set for our purpose, and the national character set, default language, and default territory, which are all selected by default. Connection mode will be dedicated server mode, and sample schemas, we are not creating them in this database. Click next. Now we can configure this database with a Enterprise Manager Database Express, but we don't want to do that now because anyway we are going to register this database with the OEM that we are going to install in the future. And similarly, register with Enterprise Manager Cloud Control will also be unselected because we don't have an Enterprise Manager Cloud Control yet. Click Next, and we will use the same administrative password for sys and system OEM repo. So for now, I am selecting a simple password here as the name of the database itself. Click Next, and it's asking to confirm that I am okay with this password, which does not meet the standard. Click Yes. Now in this screen, we will select the Create Database option here, Save as Database Template, and Generate Database Creation Scripts. These are not required. Now these all initialization parameters, this is giving us an option to take a look at the initialization parameters that are selected or set by default. We will not make any change on them as of now, and if required, we will be able to do that later on. Then click on this Customize Storage Locations button, and this will show us all the locations that is being used for the different components of files. The control file distributed in two file systems, although we don't want to keep the control file in the U005 or U006 file system. Similarly, for the redo log files, we don't want to keep them in this file system U005, and instead we have created 3 separate file systems to keep the multiplexed version of the control file and redo log files. But even if we make any changes here, because of a bug, that change is not implemented by DBCA, so we are not going to make any changes here and let the DBCA choose the path. And once the database creation is completed, we will make our changes to create multiplexed version of the control file and redo log files. And for the table spaces, we see the size which is allocated. We are okay with that as of now. And all the data files also, which are distributed in the U005 file system, which is as per our expectation. And these files are all with automatically extend on. And this is important because this is one of the criteria when you install OEM, and it will ask for setting the auto extension of the data files on. Now we did not make any change here, and we'll close this, then click Next. And in this screen, we get the last chance to review the different options we selected, and then click Finish. And the database creation is going to take around 5 to 10 minutes based on the size. In this case, this is not going to take more than 10 minutes. And I will pause the video and we will resume once the database creation is completed. So our database creation is completed after around 10 minutes. We will close this window and we will validate a couple of things about the database. First, we'll go to the bash profile, and where we will adjust the environment variables that we set before. So vi, and here all the other things are good. We just need to modify this Oracle SID, which is going to be OEM repo, and also the unique name will be OEM repo. All the other settings are good, so we'll just leave it like that. Next, we will check the listener status. And we see there are 2 listeners running. One is the default listener that we created in the previous tutorial, and this listener underscore OEM is the one that we created in this tutorial just for the OEM repository database. Now we'll see the listener status. And in the status, we can see that our new database is successfully registered with the listener. Now we'll try to log into the database using system user, and we'll see if the TNS is properly working. System @OEM repo. This is the TNS entry that was created already, and the password will be same as the database name, and we are able to connect. Just for information purpose, I will also show you the TNS entry that was created. So clear the window and we'll do a cat of the tns names.ora file in this location. And this is the TNS entry that was created. In the next, we will establish the best practices and standards in the database that we created with the name OEM repo. Please note that our test environment being a virtual environment, we will not establish all these standards, and in fact some of these are just for your information and will be useful while creating an actual Oracle database for a production environment. So these are the 15 most common best practices or standards that we should be following with an Oracle database. Enabling archive log mode, adjust the fast recovery area, create 3 redo log groups with 2 members each, multiplex the control file into at least 3 different locations, adjust the process parameter to a higher value, enable flashback and flashback retention target to at least 24 hours, adjust the control file keep record time to 15 days at least, set up full and incremental backups for the database, set up periodic and threshold-based archive log backups, apply latest PSU or patch set updates, use a non-default listener port, create profiles for normal users, application users, and DBA users, enforce password complexity through password verify function and profiles, enable housekeeping scripts, and enabling auditing in the database level. So now let's apply these standards to our OEM repo database. So let's connect to our server named admin server. Let's sudo to Oracle user and connect to our database using SQL Plus as sysdba. First of all, before making any changes to the parameters or the environment, we will create a text parameter file from the SP file. Next, we will check the archive log mode is enabled or not using the archive log list command, and we see that it is disabled currently, and we can enable the archive log mode when the database is in mount mode. So we have to restart the database and mount it first to change the archive log mode. So we'll shut it down first, then start it up in the mount mode. Please note that whatever commands I'm going to use here, those are all listed in the description of this video below. To save time, I am just copying those commands from a text document and pasting it here. If you want, you can copy all those commands from the description of this video below, or a link that I'm going to specify for a text document in my shared Google Drive. Next, we'll be enabling the archive log mode with the alter database archive log command. So database is changed to archive log mode. Now we'll shut it down and start it up afresh. Startup open. Next, we will adjust the fast recovery area to make sure we have the recovery related files like archive log or flashback logs or even backup pieces are readily available in the disk. So first, we'll check the recovery area specifications. We have this recovery area under U0006 file system, and it is sized at 7 gigs. And we know that this particular file system has enough space when we design the server. So we can see how much space is there in this file system, and we see that there are 25 gigs available at this time. So we will change the fast recovery area to at least 24 gigs using alter system set db recovery file disk size to 24 gigs, scope equal to both. And then we have to create 3 redo log groups of 2 members each for better performance and availability of the database. Right now, let's see how many redo log groups are there, and we see that there are only 3 groups with 1 member each. So first, we have to delete these groups with 1 member, and we'll recreate these groups with 2 members each. And the members will be distributed across the file systems we designated for them. So first, we will create the locations where all these redo log file members will be created. and this is going to be a host command, and our file system designated for the redo log files are U002, U003 and U004, and we are going to create these specific folders there under those file systems. And next we will see what is the status of the redo log groups, whether they are currently being used. If it is used, then we will not be able to drop it and recreate them. So we have to first check what is the status. And we see that the group number 1 is currently in use, so we cannot drop it. Instead, we will create the group number 2 and 3. So to do that, first we will drop the redo log group 2, and we will create it with this command: alter database add log file group 2, and the 2 members in this group are distributed in the U003 file system and 4 file systems. So this is the naming convention. The first number is specified for the group, and the next number in the file name is specifying the member number. So redo log 021 is the first, redo log 022 is the second member, and both these members are going to be of 200 MB in size. Similarly, we will drop the redo log group 3 and recreate it with the 2 members with size 200 MB each, and those are going to be created in the file systems U004 and 2. Now let's see the status of the first group again. We see that it's still current, and if it is current, then we cannot drop this group. So first we have to force it to go to the next group, which we just created, that is the group number 2. So alter system switch log file will do this magic for us, and we can see again, so it is still active. It means it's not going to allow us to delete. So let's do this again and check the status again. It is still active. Let's do the alter system switch log file again and see. Yes, it is inactive now because I switched the log file more than what I should have done. That's the reason it went back to the group number 1 again, and I had to do a couple of more alter system switch log files. But now it is inactive and we are going to drop it. So drop log file group 1, and we will create the 2 members in the file systems U002 and U003. So you can see that for the first group, the 2 members are distributed in U002 and 3. For the second group, it is 3 and 4, and for the third group, it's 4 and 2. So it is distributed in a cyclic fashion. So now we will see our redo log groups again. So we have 3 groups, 200 MB in size, and there are 2 members each. So each member has a size of 200 MB, and we can see all these log files we created. So 2 members each. Now we will have to multiplex the control file into at least 3 different locations. It's for integrity and availability of the database. So first, let's see what is the current control file's parameter value. We can see that it is now distributing the control file in 2 locations, that is the U005 and in the fast recovery area itself. But these 2 locations are not what we wanted. Now we'll set the control files parameter to have the control files distributed across these 3 different file systems. The first one will be in U002, the second one will be U003, and the third one will be in U004. But this parameter will require the database to be bounced for the changes to take effect. So we are doing it through the scope equal to sp file parameter, so that when we will restart the database, the changes will take effect. Now, before we restart the database, there is one more parameter which also needs a restart of the database for the changes to take effect. So we will change that parameter as well before we restart the database. So let's check the current value of the processes parameter, which is 300, and it's very low. So we will set it to something like 2000 before we restart the database, and the scope here is SV file again. And now we can shut down the database. So our database is shut down. Now we will go back to the OS prompt and make necessary changes so the control file is copied to the appropriate locations. First one, so we'll move the control file in the U005 location to U002 location. So we'll move it. Similarly, we will also move the control file in the first recovery area to the U003 location. That is done. And we will make a copy of the second control file to create a third one. That is, the control file in U003 will be copied to U004 location. So all our changes in the operating system level for the control file are done. Now we can restart the database. So again, SQL plus /s sysdba, and now we can start the database. So database is open, and we can check the value of the control files parameter again. And now we can see that there are 3 control files which are distributed in these 3 locations we designated. Also, let's check the process parameter value, which should be 2000, and yes, it is 2000. Now we need to check whether the flashback is enabled in our database. So this is actually important for faster recoverability of the database. So first we'll check whether the database has flashback enabled or not. Set lines 300, pages 300 to set the SQL plus environment, and we see that the flashback value for the database is no. So we have to set this. So this is an online parameter, so we don't have to bounce the database for the changes to take effect. So we can enable the flashback in the database using the command alter database flashback on, and the flashback is on in the database. To verify it again, now we can see that the flashback is on. Now let's check the control file records keep time parameter, and we see that the current value is 7, which is very low. Although it is an optional parameter for you, if you are not using a recovery catalog, I suggest you set it to at least 15 or higher. So for now, we'll set it to a value like 30. So alter system set control files record keep time equal to 30, scope both. Now, a few of the standards like setting up the incremental backups and set up a periodic and threshold based archive log backups, and also apply the latest PSU, these 3 things we are not going to apply here in our virtual database for obvious reason, and we will cover these topics in a separate video outside of this series. For example, setting up a periodic and threshold based archive log is very important. A periodic backup will make sure that the archive location is freed up periodically, and a threshold based archive log backup is important because, say, on a particular day there is a massive activity which is executing a lot of DDL and DML operations in the database, which is causing a lot of archive logs to be generated, which is more than usual and more than the average archive logs that gets generated every hour. Now, if your periodic archive log backup runs every hour, it is highly likely that your archive location will be filled up even before the next run of the archive log backup job clears up the space. It's because in that case, if you have a threshold based archive log backup script that periodically, say every 5 minutes or 10 minutes, if it checks the archive location for its occupancy or what percentage of the file system is being used, and you set a threshold like, say, when it is more than 40%, this backup job will run. Then whenever that massive DML activity is going on, generating a lot of archive logs, and even before it reaches the 100% and brings your database to a standstill, the threshold based archive log backup script will execute the archive log backup job, and it will clear the archive location, which will also prevent the database from going to a standstill or frozen because of the archive location is 100% full. Next thing, we will make sure that the listener is not listening in a default location. So if we see the local listener parameter for this database, we see that it is having the string value listener OEM repo, and we can just using this tns ping command at host level, we can find out whether it is listening at the default port or something else. So we can see that the port is 1522, which is not default port 1521. So we are good in this aspect. And also we should create profile for normal users, application users, and DB users to maintain uniform limits within each set of users and also security of the database. So if we see what are the current profiles created in the database, we see that there are 3 profiles: default, Aura Stig profile, and GSM profile. These 2 are created by Oracle itself, but for us we have only the default profile, which is not good. So we have to create profiles for our different set of users based on the requirements. Next, enforce the password complexity through password verify function and profiles. This is to keep your database secure. If we see that currently our default profile has no password verify function assigned, if you see that the value of the password verify function is null, means the default profile is not enforcing any password verification or complexity function. So this is a risk to the database, and we should always use a password verify function, which is actually provided by Oracle, and if we want, we can use it in our profile. Next one is the enabling of housekeeping scripts. This is to make sure that unwanted or very old trace files, dump files, log files, or audit files do not fill up your database server storage space. So you can set up OS-based scripts which will periodically run and inspects the locations where these files are created and delete them based on their age. Say any files older than 30 days or 15 days will be deleted automatically. This will make sure that this space utilization is under control for these files. So there are multiple ways to achieve this. You can create OS-based scripts and schedule them on cron tab or in OEM or as database jobs also. We will discuss this in a separate video as this is not within the current scope. Next is enabling the auditing in database level. This is to maintain vigilance and security of the database. If we see what is the current value of the audit trail parameter, we'll be able to find out. We can see that the audit trail parameter is set to DB, means auditing is enabled at DB level. So this is how we establish the most common Oracle DB standards and best practices to avoid facing issues over time. Please note that the items I demonstrated are informational and for knowledge purpose. There may be many more or maybe even less number of standards that you need to follow, which depends on your environment or even case-to-case basis. So viewers, I hope you enjoyed the video and found it useful. Please hit the like button if you liked it and subscribe to my channel so you won't miss an episode in this series for the Oracle DBAs or similar educational videos that I am uploading every week.